Hey, everybody. Welcome to Data Engineers Lunch number 20. Today, our topic is, it's actually just a discussion of, what's the difference between data operations and data engineering, dev operations, or DevOps versus DataOps. It's a question that I've been asked, and I'm also very curious, what people think about this. But I see it on a day-to-day basis at client work, where sometimes people use it interchangeably, or rather they don't make a distinction between the two. And I think there are some distinctions. Also, the question is like, what aspect of this is actually data engineering, right? As we discuss this, I'm going to take notes from what you guys feel and actually help produce a blog post that hopefully kind of clarifies this. There's a lot of stuff out there, but I think that this distinction is fairly new. It is relatively new compared to DevOps. I would say in the last 3 to 4 years, this terminology has started up. I'm an organizer here, looking for co-organizers. We are part of a much bigger, broader community of data practitioners called Data Community DC. What does a co-organizer do? Well, it's actually being part of not only helping this group get speakers and topics and maybe even present, but also to work with the larger data community DC. And I'll talk a little bit about that in a little bit. Data Community DC is a diverse group of individuals. We're always looking for people from different backgrounds to come and present, especially from underrepresented races, genders, sexual orientations, etc. Data Community DC is, as I mentioned, a group of meetups, actually, and then beyond that, there is a conference that gets put out every year. This year, I'm not sure if it's going to be physical or not. It's just in the planning stages. If you're interested, go to dataweekdc.com. What do we cover here? We cover the get your shit together problem of data. I would even say that we're starting to cover some data operations type topics here. But data engineering is about getting the data and engineering the code or processes to clean up that information and or even execute some of the data science processes such that the data gets clean enough for visualization in dashboards, clean enough for data exploration, for further analysis and processing, or clean enough for data scientists to then take the data and do more with it. Anyone that wants to say hi? Normally in a physical meetup, we would have folks introduce themselves and just say a little bit about themselves. I used to pick people, but if you're too shy, that's okay. At any point, you can turn your camera on and say hi if you'd like. Yeah, go ahead. Jonathan, would you like to say hi?
Yeah, Jonathan McDonald. I think this is my first data engineers lunch. So just kind of listening. I worked as a government contractor for many years, doing data cleanup and the manual drudgery that is. And then I've since now worked for the government directly. And I still do the same data drudgery. I'm doing it right now, so it's awesome.
Yeah, actually, that's great, and love to get your thoughts on what part of the work you do could be considered potential data operations automations versus whether it's a DevOps or was it a DataOps or data engineering challenge. So be good to get your thoughts on that. Yeah, big part of a lot of data stuff is manual still, and but the thing that cannot be automated is maybe in the future, is the understanding what it is and understanding what to do, right? That's what the machine can't yet do. You still have to give it a little bit of input and a little bit of expected output. So we have that part of the job secure. Anyone else want to say hi? Okay, excellent. Group rules, if you have a question, ask it. It doesn't have to be a question. It could just be a comment on what's being talked about. As I mentioned today, it's a discussion. I'm just walking through, what I see as the differences between data ops and DevOps, and love to get your thoughts on it. Just be polite if you want. You can also ask in the chat something. And sometimes I don't see it because my chat window is hidden. But most of the time I'll pick it up. Our company, I work here, Anant, we do data platforms. We help design, build, and manage data platforms. So data ops, DevOps, data engineering is a big part of what we do. We mainly focus on real-time data or fast data. DataStax is a partner and sponsor of this group. So is George Washington University. And we have some local sponsors in the DC and Chicago area. Our organizational sponsors help sponsor the larger data community DC and help put on events like Data Week DC. Anyone have a meetup or a job announcement or looking for a job that would like to say hi, introduce themselves? Okay. As I mentioned, Data Week DC is happening this year. I'm going to bring this up. Let's see, October 6th to the 10th. Right now it's empty because I literally think they just refreshed this website and it's definitely under construction. But if you're interested in getting involved as a volunteer, feel free to reach out on Data Week DC or Data Community DC. Data Community DC has an index of all of the different meetups out there. So let's see, we got now there's blockchain DC or distributed health DC. So you can always check those out. I don't know, they used to keep a kind of an events page with all of the meetups, upcoming events, but maybe they just advertise it on the Facebook group. But I don't see anything upcoming. There's usually something on the statistical seminars. Yeah, look, a lot of these are, we don't have anything new, but let me see. Statistical seminars, I know has a workshop coming up. Yep, it's tomorrow, Interactive Graphics and Beyond with R. How's federal statistical system coping with the COVID? That looks interesting. Best practices on contributing to statistical community forums. All right. We also have a weekly, this event is weekly, every Monday, same time, same place. And we have an upcoming talk coming either late April or early May related to Prometheus and Grafana. And if you're interested, let me know in chat if you want to do a presentation. We are generally going through a roadmap of what does it take to be a data engineer, and every now and then somebody has a topic. We just put that into the queue for the next talk. All right. With that, I'll just go ahead and get started. This, as I mentioned, is a discussion on what is the difference between data ops versus DevOps. I look at DevOps as kind of, as I mentioned earlier, a relatively new distinction in the technical engineering world that came out of what people have learned from DevOps, which came out of Agile development and lean manufacturing, which is how do you get robots to do some things for you so that human beings can leverage their mind power for higher value work. So when DevOps came around, it was if we want to do quick releases and quick iterations for the end user, which is people, how do we improve the processes so that people can benefit, and then eventually how do we use tools to implement those processes, right? So in DevOps, it was about producing software so that the end users could use it quicker. In data operations, it's how do we use processes and tools to get data to people quicker, whoever the audience may be, whether it's a data scientist, whether it's a data analyst that's going to put together the dashboard. And then once the dashboard is built, right, how can we automate it so that the end user, the person who's looking at the dashboards, after data analyst has made them pretty and, made them make sense of whatever underlying insights the data can show, that those people get continuous fresh updates to that dashboard, right? So at the end of the day, it's still about people. In DevOps, we're talking about producing software that people can use. In data operations, we're talking about producing data products that people can use. Sometimes people will combine the two. And I think that's something I've definitely seen is a lot of teams still call the whole team DevOps in a data group, right? In a chief of data office, there will be a DevOps group, and inside DevOps, there will be maybe machine learning operations. And then there's definitely data engineering going on, but then there's basically that data operations. But there's not yet a distinction yet. So what I really want to do is like separate the two there's definitely overlap, but just separate the two so we understand what is the core skill required for somebody to be a good data operations person in this ecosystem of DevOps, in this ecosystem of, everything is automated, and with the mission of getting the data to the user or getting the product to the user. And I don't think it's going to be, unless you work for a very, very large company, DevOps and DataOps are like kind of sitting next to each other. People will do a release of their code, it'll get put into development, right? And data operations will take it over and they'll run it and make sure it works. And then it gets promoted to the next stage and then eventually to production. So side by side, right? Dev operations is making sure the engineering of the solutions is moving forward in environments after validation and testing. And data operations people are making sure the data is getting validated and tested and it's of high quality as it continues to move forward. This is by no means a very comprehensive distinction, but in data operations, what we're basically seeing as the value is the data engineering itself, any analytics around the data, maybe data science, maybe business intelligence, but the end. Thanks, Siri. Data operations is essentially delivering to the business or the end user higher order data products that the raw data itself can't give them, right? And it could be an Excel report. It could be a Tableau dashboard. It could be a model that is continuously running and then enhancing data, and that enhanced data is what they're seeing. DevOps, on the other hand, and what I failed to mention is that sometimes this means it is an API that is backed by the clean data that data operations is producing, even though the API engineering is really mostly part of dev operations. In dev operations, the value that is being delivered to the business or the end user is the software engineering. Whatever the end product of the application development, that gets delivered as a product, as a feature or whatever. There's a cycle of potentially code reviews to make sure only good code goes into production. There's possibly testing to make sure that after every build that at least working compilable code goes to production, and at least there's no obvious functional issues. And then there's the monitoring. And I would say there's even a monitoring aspect of data operations, but it's the monitoring of everything, like the logs, the metrics of the application, to make sure that as the system is running, people are watching the core KPIs of the system so that they can improve it. That's a feedback loop to make the software better. And this is where maybe there's another area called site reliability engineering, which is slightly bigger. That's the making sure that the production system is always up and always performant. And site reliability generally has good feedback for dev operations, if not owns some part of it. Or site reliability may have great feedback for data operations to say, hey, we're noticing some latencies and this type of request for this data. Can you guys take a look and see if there's anything wrong with your data model, right? So where did DevOps come from? If you haven't heard the term DevOps, you're probably living, you have your head in the sand. A lot of people will throw the word around and confuse it with CICD, which is just a tool. People will mention DevOps when they're maybe just talking about containerization, or maybe this idea of infrastructure as code. But DevOps is more than that. DevOps is a whole set of practices and principles and methods that people use. Actually, there's a really good checklist that I had found. I might not be able to find it immediately. But if you just look for like DevOps checklist, you can see how comprehensive it could be, right? What is your alignment? What is your context? This is a little bit too business oriented. Let's go down to like technical, cross-functional team, communications culture. Let's see, things like open and shared spaces, customer-oriented culture, source control. Again, people will say DevOps is just source control. That's just a big part of it, but it's not everything, right? Infrastructure as code, as we talked about, automations to help build the infrastructure, to integrate, to compile, to deliver the software, to have feedback loops. So DevOps is a fairly big area of engineering, which is not just one of those things, right? And this is important to know that like data operations, as it continues to mature, is in the same space. It is not just, data operations is like learning how to use Airflow. Nah, that's not it. Like there's more to it than that, right? Data operations is making sure you know how to run Spark jobs. Like, yeah, okay, that's one part of it, but that's not all data operations, right? Let's see if there's and people take it from whatever business or industry or technology they use, and they attach their labeling on it. But everybody has a slightly different checklist, right? Here's one that talks about, do you build AMIs? Well, you know what? If you're on premise, you won't need to really build AMIs, right? Or this one obviously looks like it's like an AWS DevOps checklist, which doesn't make sense if you're using Azure, for example, or if you're on premise, like I mentioned earlier. So this stuff will get published. The value, so it came out as DevOps came out as a practice of operations development, really out of the agile and lean manufacturing movement of you use people for the thing that they're best at, which is doing more than what robots do. And in agile, it was about, deliver quickly, deliver often to the end user, get feedback on the software, put it back into the software so that it's better for the next iteration. And there's different agile methodologies. I'm not going to get into that, but the idea of having a good velocity to deliver value. And so DevOps became, how do we do that with technology? How do we do that with processes? And still aligning with the agile principle of people over processes over tools. Meaning we're delivering something to the end user. Can we then use the right process to make that quicker, better, faster? And can we use tools to then deliver the processes better to the people? So I didn't put everything in here, but like, infrastructure as code, being that if we need to build the production environment as much as possible, can we have everything ready to go where we push a button and get the whole production environment? That's not just good for replicating a production environment for stress testing. It's also good for disaster recovery. Do it right, do it once. What it comes down to is that, when you are automating something, think about if we can do it once as a repeatable process. If we take a repeatable process and we do it once, let's do it right the first time, so that at the very least we save time. It doesn't have to be perfect, but just do it, right enough. And then there's other, DevOps principles that again align with Agile. Here's just a few. The practices are different for different companies, but I would say source control, obviously, being one, right? Have your stuff in source control. You cannot believe this, but there are companies that we don't work with them, thankfully, where their source control is like, they'll have a source control, but they will make a backup of it in production to try out a change. And they'll have like 10 different directories of backups from like 2019 and 2018. I'm like, you have source control. Like, why are you doing this? And basically what they're doing is they're not using source control properly, and they're not doing configuration management, which is you have one source, your master source, and each environment is a configuration of the master source. And you can have source control store your source code, and some people will store configuration management in a different repository for security reasons, or they'll use things like Vault or Console to store the configuration for their software, so that you deploy the software and you say, deploy the software for production. It will get all the credentials and the configuration information for production, and it will use that to then deploy the software or to deploy the infrastructure, right? Another common metric is measuring everything, measuring how long the application takes to do certain functions, right? Using profiling tools, using application monitoring tools that go deeper. I'm not going to endorse any in particular, but like when your system starts up initially, it would be nice to know how long it took, especially if you have 100 servers where 100 instances of your software is coming up, right? So you want to know how long things take. Or if there's an API call, knowing how long it took. It's not just a web server log question. It's the web server will tell you when the request was hit and when the data got sent. But there's a lot going on in your API. Like, okay, it took us, out of the 500 milliseconds, it took us 450 milliseconds to get the data. What can we do to reduce the 450 milliseconds to, let's say, 250 milliseconds, right? If you don't know what's going on, then you can't really improve it. And then obviously monitoring. DevOps means monitoring every stage of the development and then eventually the production environments, so that we're talking about having logs aggregated, automatically being scanned for error, warning. And so needless to say, if your software is not logging something, then you can't really alert on an error when you're not logging it. If the only thing that you're alerting on is null pointer exception, you might miss the 200 other exceptions that are out there. So practices, again, this is not comprehensive. These are just some of the common ones. And then we have tools such as CICD. And so here I'm going to mention some tools. Again, I'm not recommending any in particular, but people use things like Jenkins, which is an open source tool. They'll use Circle CI, which is a software as a service tool, or TeamCity, which is a commercial tool. And then there's many, many, many more. All of the clouds now have their own kind of version of their DevOps tool. Like Azure has like Azure DevOps, I think that's what it is, ADO. I think Google has something called Google Build. Does anybody know what the one for AWS is? It could just be AWS DevOps. In fact, it is AWS DevOps. I could have guessed that one. So what do these tools do? Well, they do two things. They do continuous integration and continuous delivery. You don't need to have continuous delivery. You can just do continuous integration. What is integration? It's pull down the code, right? When code is committed, build it. If it builds, run it, run some tests. You can even have some unit tests before running it and doing some runtime tests. You can even do whatever. I'm not going through all of CICD, but the point is that by the time this process, this is automated, right? This is all automated. By the time you commit your code, you go get a cup of coffee, you'll get a little light that says, hey, this thing went okay. It's already been deployed to dev, and we've tested it for you. There's no crazy bugs. Now, continuous delivery would be getting it into dev and stage and production with a push of a button. So one button deployment of the whole stack or some parts of it. Right, so it looks good. Okay, push to stage. Looks good. Push to prod, right? So this is continuous integration, continuous delivery. You could be an expert at one of these tools and be highly paid just because you know this part of DevOps. You don't have to know anything else. Well, you kind of have to know other stuff. But none of this stuff really goes that well unless you have good configuration management in place. And let's say for configuration management, we can talk about Vault, console. People will even use Git for storing the environment variables for different environments in a different repository. But in addition to that, we have things like Chef, Puppet, Ansible, right? And these work generally with any hardware, any infrastructure. It doesn't matter if it's on-premise or on the cloud, right? There's more. I would say you can even use Docker for this, but I would say that's probably under containerization, which is a way to manage your configuration. Orchestration. So what we're talking about here is Terraform, CloudFormation. There's even like VMware has its own way of doing like a private. You can even have VMware plus Terraform, for example. Virtualization is one way to deal with delivering software. So if you're on premise, you use VMware or something else. You can open, I think it's called OpenShift or OpenStack. I keep confusing which one is what. But virtualization is basically saying, my whole environment is virtual machines. So I can say, build out the virtual machine, deploy the software using Ansible, right? Everything just comes up as expected. And then finally, containerization is probably the name of the game now, using Kubernetes, Docker. You can use other tools, but I don't think they matter that much right now. So that's DevOps. Why did I go through all of this stuff? Because I think that to be a good data operations person, you should understand where certain practices came from. And more than likely, the initial data operations work is done in this context. As we've seen with several presentations, we can even use Jenkins to do some data operations for us. So if you already have that infrastructure, right, get chummy with your DevOps people. You can use all of this, all the tooling to do some of your data operations work. All right, I'm going to pause for a second because I've been speaking for a little while. Any thoughts, insights on DevOps that I haven't brought up? And as I said, this is just a quick survey of the concepts. Love to hear from you before we go into DataOps. Okay. Going once, going twice. Okay, let's continue. So data operations is taking the agile approach to design, implement, maintain this distributed data architecture, which then delivers the data. Okay, and you kind of have to have a little bit of DevOps knowledge and data engineering knowledge to be able to do this. So if we take everything we learned in DevOps And then we put that filter to say, let's take everything we've learned from DevOps and add to it, what are we trying to do with DevOps, which is to produce dashboards and maybe APIs, or even Excel files. What are the things that we use? Well, one of the big things we start with is the value, right? People over processes over tools. Same exact value, right? It doesn't make any difference if you're using DataOps or DevOps. Eventually, the goal is that you're producing something for people and you're implementing certain processes, and maybe you're using tools to implement those processes. Same general principles of like infrastructure as code, do it right, do it once. At the end of the day, we're basically using the same general values and principles. When it comes to practices, here's where it slightly delineates. And I would say it actually inherits many of the things that we do in DevOps, but it adds on to it. So we still want to do source control. I'll get into that in a second. I'll put here. Still want to do source control for potentially the metadata and the rules, right, around how to process something. Let's say you have a data engineering process and it kind of does the same thing for most situations. The only thing that may change is the number of columns and the column types. If you have your data engineering intelligent such that given the raw data and given a set of mappings or rules, it basically takes those, does the process. Different type of data comes up, it can take the metadata, do the same process, but with different metadata, different data. That's a great process in which what you've done is now built a product, built a tool, and anytime new data comes up, all we do is we create new rules or we create new metadata. That helps us do our job faster, right? We're not copying and pasting code. We're taking our engineering knowledge and then elevating it to, we've made a robot. We just need to give it the right inputs and it'll do the job. And every now and then we'll go and tweak the robot to do some more things. And so that means that beyond the metadata and there are semantic rules for processing certain types of information, you may have slightly different sources of data in dev versus stage versus QA. So how do we manage that? That could be done with configuration management. Metrics, I kind of already have this, but when the system is executing, how long did it take for stage 1, stage 2, stage 3, stage 4? And within the last build of the software or the last pipeline execution, did anything change? Did we go from processing the data in 8 hours to doing it in 16 hours? What happened between then? And that is very important if you're in a business critical environment where the data needs to be refreshed on a regular basis, right? You need to monitor how long things are taking. And the monitoring also means monitoring all the components of it, especially if we're working in a very large scale distributed compute environment like Spark, and you have 100 nodes with hundreds of if not thousands of executors, right? Monitoring and seeing what's my threshold of pain, how many executors am I going to let fail before I go and check out what's happening. The same principles of monitoring with logging and having alerts in place. The same thing matters in data operations, because if we don't monitor the process, the pipeline execution, it could mean bad news for our end users. It could mean that the end users don't get what they need. Another facet of Agile and DevOps we bring to data operations is having some sort of feedback loop. So at the very least, when the data is pulled, processed, and delivered, you have some basic validation. So if I pulled 100 records and I applied my classification, prediction, whatever, and I saved it somewhere, but I only saved 98 records, something is off, right? I missed something. Even if, like, I'm just making this as an example, like if you have 100 records, in good practice, you wouldn't not save the data. You would say, I wasn't able to classify these two. There was something wrong with it. And you'd save it. And then when you validated it, you would say, how many unvalidated records were there? Oh, 0 unvalidated records. Great. We're good to go. Nothing is wrong with the world. Everything can move forward. The next step in the pipeline should take over. Or it could be, let the 98 records continue on with the process, but let's alert people that 2 records were screwed, or let's retry that process. And to have some validation. And again, I'm assuming business critical environment, but this obviously applies to health critical and mission critical. For you guys, mission critical means that people are going to die, right? Health critical means that they're going to get sick or die. Business critical means that people will lose money. So when people say mission critical, like ask the question, like, people, are they going to die? If they're going to die, like, you better make your data process good, right? You want to have all of these things in place so that you are 100% sure that when your data process goes to production, people are aware of what's happening, right? Because at that point in today's world, at that point, when it gets to production in a mission critical or business critical or a health critical environment, there's a loss that could happen if that certain alert or check was not put in place. Worst case scenario, somebody looks at it in 5 minutes and figures something out and resolves it. There's only 5 minutes of loss, or whatever that is, right? And then, needless to say, automate as much of the process of the data pipeline, right? Like, if we're going to follow all of the stuff we learned in Agile and in DevOps, we should automate it, right? Anytime new build of the software gets deployed, the data pipeline should just pick it up and just continue with it. Right? We shouldn't pause the data pipeline. Well, sometimes you may have to. Pause everything. Let me deploy the software first. Let me copy over all the files. Okay, now you can turn it on. Now that's just old school. Push a button. Software is deployed. Your scheduling engine, which we'll talk about in a second, may take a look and say, okay, yeah, everything looks good. We can continue because all the systems are up. Right? All the data sources are in place. All the data syncs are in place. Everything's good to go. Let's go ahead and do it. Okay. And the tooling is, again, very similar. The only thing I added here, all these are kind of inherited from DevOps. Most of them are. Right. So same thing. CICD. What does CICD mean for data operations? Well, it could mean that when new data comes in, there's a trigger to get the data pipeline to pick it up and process it. There's various ways to do that. But let's say in AWS, when you send files to S3, you can have a trigger from that event put into a queue, or it can trigger like a Lambda event or something, and it will trigger the process for you. Configuration management. We talked about this earlier, storing the configuration of the platform somewhere such that it's easy to replicate. So configuration management and data operations could mean source control. It could also mean leveraging tools like Airflow or Luigi, where you have the configuration of your data pipeline components as almost like it's a metadata. Right? All the core components aren't changing much, but you're taking the metadata for X data, using this component to process it and go to the next step. So the whole process, the whole pipeline itself is kind of like a configuration. And then that configuration has a configuration. What does it look like in dev? What does it look like in prod? What does it look like in test? Orchestration, virtualization, containerization. I don't see this often where, like, to run a new data pipeline, you destroy everything and start again. But there are times, actually, there's one case where I don't see Jagdeep on, but he's worked in a big data environment where the cost of computing was so high, right? In bare metal, it was like 100 physical computers that were running the whole time. When they went to the cloud, they would look at the data size. They would determine roughly how many computers they needed for their Elastic MapReduce cluster, which is Hadoop on the cloud on AWS. They would create the cluster. They would execute the data process in that particular service level agreement. And then they would destroy the cluster. And so basically data was put into S3, cluster gets built, all this stuff happens, all this fanfare, cluster gets destroyed, data gets put back into S3 or whatever downstream database. And so they were able to run a huge cluster for like, 100 grand an hour, but it's 200 grand if it ran for 2 hours, right? Instead of, who knows how much it would be every month if all the machines were up and running. So there is a bit of this used in very kind of niche scenarios, but with Kubernetes, it's kind of the name of the game. Process comes up, does the execution, goes away. Process comes up, does the execution, goes away. In fact, the newer version of Airflow, which is one of the data operations scheduling tools, it actually runs a lot of the agents on Kubernetes. Right? It takes the thing that needs to happen, puts it in a containerized engine, container comes up, does the job, it's done. If it has to do many, many instances of that process, farms it out on multiple pods, executes it, gets it done. But scheduling, this is like, even if you don't do a lot of this stuff, right? You should. Scheduling like a job beyond cron, right? That's what I'm saying. Beyond cron, what can you do? Because with things like Airflow and even Jenkins, and we learned about Luigi, there's also things like Cloud Run. There's also Kubernetes pods for jobs, right? They come and go. How do you take a distributed architecture, which is more than one computer, right? And a cron tab it exists on one machine. So what are you saying? You're gonna run some complex orchestration of cron jobs on 100 machines? I mean, you could, technically, nothing wrong with that. But what we get with all this is that you're getting a bit of the configuration management. You're getting a bit of the containerization there. But by no means do you have to do all this stuff. And finally, one of my favorites is, again, there's other tools in data operations, but is data catalogs, right? Giving the user, right, one place to find the data. And it could mean, here's the end product of this process, or it could also show this data comes from this process, and this process gets the data from here, and this data comes from this process, and that's the provenance or the lineage of the data. What did I miss here in terms of tools? Data profiling, I think, is probably somewhere as more like a practice to make sure that every run of the pipeline we have some dashboard that shows us cardinality. It shows us the sizes, the frequency of certain type of information. Those are like really nice to have because those could be a metric for potential risks or rewards, but it's good to have that knowledge. So that's my perspective on the difference between DevOps and data operations. Where does data engineering fit into all of this? Data engineering is taking whatever humanly created code. Data engineering is taking that data and making the process that executes via data operations, making that's the data engineering aspect of it. Data operations is then taking it and then operationalizing it. Some people say that, okay, well, isn't that data engineering in general? My data scientist gave me this model and I'm putting it into production. Like, yeah, but that's just putting it into production. That's just you making sure it can run on 100 computers. That's data engineering. But to do it predictably as part of a pipeline, scheduled, push button execution, repeatable execution, that's data operations, right? Anybody can make a burger, but McDonald's can sell 1 billion burgers, right? Anybody can make a pizza, but Pizza Hut and Domino's can deliver 1 million pizzas. So data operations is taking data engineering, which is like the cooking, and then really bringing it to scale. And that's why it's a fascinating subject, is that the moment we mentioned DevOps, we're talking about big shit. DevOps can work on small software, right? It can work on big software, but like you don't really have to do data operations for small data. You don't have to. It's like overkill, right? Data operations by virtue is you need to do this. If you're dealing with a lot of data for a very big cause, for very big impact, you have to learn how to do data operations. You have to learn how to do dev operations. So it's like big boy shit or big girl shit or whatever, whatever floats your boat. It is an important aspect of platform management, that it may not be completely discerned and delineated from DevOps in wherever you work. But if you're dealing with big data, you're dealing with fast data, you're dealing with global platforms, or you will be, this is it. This is what makes your job easier. This is what makes the data available to people faster. And depending on what your mission is, if it's a for-profit business, it's to grow. This means less time, going into a machine, SSHing in and editing the cron tab. And more of a, let's go to Airflow and see what's happening. Okay, push a button. Or, more of a, let's go into Kibana or whatever, Splunk, to see what the latest pipeline execution runs were, right? That's why I think it's exciting to me, because it formalizes so much of the challenges that people have solved, especially in the big data world. All right, well, that's my topic discussion. I didn't really see anybody take part in the discussion, but any questions? Anybody want to talk further, maybe from your experience of DevOps or DataOps? Any tools somebody want to mention that I didn't mention already? If you're not allowed to, can people unmute? It may be that may be the case, but
Hi.
oh yeah, Caitlin, go ahead.
So actually, I have a question because I have seen some positions where they say they have a position for data engineer, and they say they have position for data ops engineer.
Yep.
And then I don't get it. Okay, like, what's the difference over there? Because as you showed us, like the data engineering is a part of data ops.
Yes. So that's a very good. Well, I should say that it is a part of data operations in general, but a data operations engineer is different from a data engineer, right? So I think you're asking what's the difference between a data engineer and a data ops engineer.
Yes.
Okay. Here's my take on it. At the get-go, to be a data ops engineer, right, you need to have some DevOps knowledge at the very least. That's a primary skill, right? And if you know data engineering, you can become a data ops engineer.
Got it.
Okay? Data engineers don't necessarily need to be well-versed in DevOps. They don't have to be. Okay. They could just be good at writing, some Spark job on their local environment, and it works, and they're able to, deploy it to production and make sure it works. But, keeping the system up and running, managing the pipelines, it could be a part, but then at that point, it becomes the data operations as a whole.
Okay.
Right. I think one way to describe it is like, so every real company has operations, right? What the company does, it's the engine of the company. And generally, IT is a part of operations, right? So company operations and you have IT engineering, right? So I would look at data operations as the whole thing. Data engineering is part of it. Data science is a part of it. But then data operations engineering is more like the internal IT of that, the internal engineering to make that whole thing run.
Okay.
And if you want to get really tactical, it's like, I would expect a data ops engineer to know containerization, distributed processing technologies like Spark and Flink, and how to get it to scale and how to redeploy it with CloudFormation or Terraform or whatever, okay? Versus a data engineer, I would expect to know different data formats and how to process them in different languages. They should be good at maybe Spark and, I don't know, maybe MapReduce.
Okay.
And if they happen to know things like Docker and Kubernetes and Terraform, okay, great. But I would say they're like, there's a little bit of overlap, but I think they're two different things.
Yeah.
Cool.
And the second question, sorry. Is Airflow is a part of both DataOps or DevOps or only DataOps?
I would say it. Well, there have been some speakers on Airflow on this group, and I see some of them right now. I would say Airflow's job is to execute code that has been delivered via DevOps.
Yeah.
Right.
Okay.
But nobody says you can't make something like a task in Airflow to pull down the source code for, so you could kind of rig it, but I would say it's like DevOps and DataOps are kind of hinging on each other.
Okay.
There was a comment, most ETL tools, Informatica, Talent, NiFi, Airflow would meet DataOps criteria, but not DevOps. Yeah, I totally agree. Yeah, I totally agree. Because they're just focused on the orchestration of the pipeline and execution of the pipeline, and less about the components that are a product of DevOps. DevOps produces source code.
Okay.
Or whatever, some artifact, some widget that does X and Y. Data operations uses widgets that take data in, put data out, and it links them together and make sure that that process continues to execute.
Okay, got it.
Cool. Yeah, thanks for bringing that up, Gautam. Good comment. Anybody else want to add or ask a question?
When we are comparing the on-premise and the cloud for the balancing and all those things, so when we are comparing, which will be you suggest for the on-premise or the cloud for the deployment and all for the auto scaling process? Like most of the companies right now are moving to AWS and Google platform, and some of them are like, when you compare the health domains, are still using on-premise, and which will be the you wants to suggest for it when we take banking sector is moving to cloud and the health sector is still in on-premise. Is it?
Yeah, it's a really good question. Unfortunately, the answer to that is generally subjective. Given all the facts, it's still a very subjective answer. And I'm going to bring back bring it back to your question. So I was on a club room talk about infrastructure companies. It was hosted by Andreas and Horowitz, and they were talking about the bleeding edge of infrastructure companies. And they were talking about things like Databricks, which they invest in, which is basically a machine learning infrastructure company or data computing infrastructure company, right? You push a button, you get a cluster, you put data, you do stuff, right? Well, in a software as a service company, especially consumer, you collect petabytes of data.
Yeah.
Right? Everything you do, they collect it. Okay.
Yeah, it may be scaling up or scaling down. We can't figure it out. Like it's a real-time data, and most of the banking sectors has like feedbacks, data transactions, like rewards transactions. It's completely like it's a real-time streaming, and the data might be at a time it will be scaling up. Sometimes it will be scaling down.
Right. Now, for real-time transactional data, yeah, it's going up and down.
Yeah.
But that same company, they're amassing petabytes of data, right? And if your data is stored here and you're using some other analytic infrastructure tool that's here, that's why you want to do AWS Databricks on AWS, for example, right? Moving the data to do the analysis and putting it back, there's a cost of moving, first of all, storing the data, moving it, processing it, putting it back, right? Yeah. And if your archival data continues to grow, yeah, the cost of operating the company gets very expensive. And just because you use reserved instances doesn't solve the problem. Yep. Right? You're talking about a cost that you could maybe go from $1 million a month because you're using some online service. If you can bring it down to $250,000 a month with 2 employees, okay, which cost whatever, 200 grand a month. Maybe it's a kind of a break-even scenario. Okay. But at some point, if you have enough information and you need to do enough computing, it makes sense to have some quote unquote on-premise, meaning not in the company's office, but like some provider, right? You go to a carrier neutral provider and you say, here's 500 computers. 500 computers, if you buy them, they're not that expensive. The labor to put them together is expensive, but they're not that expensive. And with today's technology, with the open private cloud management technologies, with things like Kubernetes, honestly, like you are 80%, if not 90% of the way there, as Google was maybe 10 years ago, meaning they would just replace hardware and everything would just continue. Okay. Right. So it's a subjective answer, I would say. Okay. But it just comes down to the industry and how much information you have, I think.
Well, I just want to know because when I was working for on-premise, they were suggesting to move to the cloud, and they are having some lot of discussions, and they're just going for the cost cutting and all those things, and for the privacy and the confidential matters there. Then I just want to get to be updated how it was. The suggestion was being.
Yeah, I think the strategy is keep your options open. Just keep your options open, right? Keep it backed up somewhere. Anyways, folks, it is the top of the hour. We are here every Monday at noon Eastern Standard Time. We'll see you guys next week. Today's topic was brought to you by all of you discussing, well, mostly me, but thank you, Ketan, for your question, and thank you, Javed, for your question. We love more questions, and if you have an interest in speaking, reach out to us. I'll put my email address in the chat. We'd love to have you talk about something. All right. Thanks, everybody. Have a wonderful week ahead.
Thank you.
Bye.
Thank you.
Have a good one.
Thank you.